Welcome to myprojectbazaar.com. Our product title is Power Energy Management for a Grid Connected PV System using Rule-Based Fuzzy Logic. Let us see about the abstract of our product. Active collaboration among green energy and the load demand lead to serious issues related to power quality and stability. This requires newer strategies to be incorporated to keep the power stability among green energy resources. And microgrid utility grid is designed presents a novel technique for power management in grid connected photovoltaic system. With an energy storage system under a set of constraints including weather conditions, load scheduling hours, peak pricing hours by using rule-based fuzzy smart controller to schedule power coming from multiple sources, that is photovoltaic grid battery. Under the above set of constraints, the technique fuzzed all the inputs and established fuzzily rule set from fuzzy outputs. Before defuzzification process, the simulation are run for 24-hour period and the rule-based power schedule is developed. The proposed fuzzy control strategy is able to sense the continuous fluctuations in photovoltaic power generation, load demands, grid load scheduling patterns, and battery state of charge in order to make correct and quick decisions. So the suggested fuzzy rule-based scheduler can operate well with input, thus does not require any exact numerical model and can handle non-linearity by combining the human heuristic into computer-aided decisions. These techniques also provide a framework for extension to handle multiple special cases for an optimized working of the system. In this proposed implementation is only done in given flow and also the given output waveform only here we present. That is a client requirement, so that only we did. Next we see the flow diagram of our process. This is our flow diagram. In this flow diagram, the input sources is a various sources. First one is the PV and battery and also grid. So those are the sources. Those sources deliver the supply depend on their consumes energy. So PV is deliver the DC supply and also battery module is deliver the DC supply, and the battery is a bidirectional converter using to convert the DC to DC boost operations, and also PV is convert their output voltage into furtherly boosted in using of DC to DC boost converter. After that, that is fed into the three-phase inverter. Three-phase inverter function is fed into AC conversion from the DC source. So DC supply is converted into AC and also that fed into the main grid. In between, the output of the main grid is connected to the load, and also the main grid, the voltage sensor is used to sensing the voltage measurement and also that is fed into the inverter control. And also the fuzzy inputs we give the SOC and PV power and so on. So that is fed into the fuzzy controller, and output of the fuzzy controller is fed into the bidirectional controller. So overall process is depends on this controller is controlling the power alternating switches. Due to controlling the power alternating switches, the output will generally green energy sources have now progressively become a vital part of the energy production since the fossil fuel reserves are getting closer to exhaustion. Amongst the renewable energy sources, solar energy is considered to be most desirable option. Though these resources are enhancing in several aspects, the problem related to them, like their irregular nature and increasing capital cost, are the core hurdles to their utilization. A hybrid energy power system along with storage battery can boost the power quality and availability. Operational efficiency and reliability of the system also considered to be increases. The growing number of green energy resources and TG needs newer strategies to be incorporated into their operation to keep the power energy stability among green energy resources and microgrid utility. Next we see about the running process of our product. In this proposed implementation is done in MATLAB simulating environment. First open the MATLAB main window, after that create a new model file. After creating the new model file, we arranging the elements from simulating library browser. From the simulating library browser we used two toolboxes. One is sim power system toolbox, another one commonly used toolbox. From that toolbox we get the elements and then arranging that elements as per the given flow diagram. After that we assign the parameters for each blocks, then create a subsystem for larger blocks, then connected the scope from commonly used block in the corresponding measurement devices, then click the run icon. After clicking that, the simulation will start to run. After that, when the simulation is entered, we open the scope, corresponding output waveform will be shown. So this is the fuzzy toolbox, and the next one is the IV curve. This curve is drawn between the current and voltage in the solar panel. And next one is the power waveform. This curve is drawn between power and voltage is getting from the PV panel, and this is the corresponding output power and voltage waveforms. And next one is the battery SOC conditions. So this is the battery voltage, next one current, and another one SOC condition. The state of charges here is 100%, and next one is the inverter output waveform, and also next we can see the controlling signal. First one load control signal, another one battery charge control signal. If 1 means that circuit breaker will be triggered, if 0 means the circuit breaker will be disconnected from the circuits. And also battery charge control, if 1 means the battery will charge, and 0 means the battery will disconnect from the source. And next one is the inverter output, and each phases here we give A, B, C, that is RYB, and the next one is the pulses waveform. So this pulses is generated by using of the fuzzy logic control and the space vector pulse width modulation. So overall process will be done in the corresponding output, so efficiency will be increases. Thank you for watching this video.